Okay, well, we've talked about Ubiquity Robotics before. This started as a sort of pseudo club project around 2.5 years ago, and the stated goal was to design a useful robotics platform capable of living in a ADA compliant space and having a bill of materials for under $500, and we're doing it. This is the first production chassis, unwelded. It was parts, and we bolted it together to see fit and form. Has our custom controller on it, our brushless hub motors. The whole project is built around the existing supply chain, as opposed to designing a very difficult to design robot and then trying to design an expensive supply chain around that. So we're going to kickstart this after Makers Fair, and so I'll do my marketing pitch. You know, everyone knows the ultimate goal of a home robot is to bring you your beverage from the refrigerator. So if you get a FiddlerBot, it can bring you a can of beer. If you get the Magni platform, it can bring you the whole keg. Okay? That's the marketing pitch one. Right now, there's no way to pick the keg up, but if you get the keg on there, it'll be able to bring you the keg. I think it'll be able to easily transport 100 pounds up a slope. So it's pretty powerful. The other thing is, if you are a designer of apps, you are not expected to have to build the phone and design the phone before you design the apps that go on the phone. So if you want to design robot applications, you should not have to design a robot from scratch. We're going to give you a platform with usable capabilities for a very affordable price. It's a developer's platform. You want to put an ARM on it, that's great. You don't think our Raspberry Pi is powerful enough computer? Put something bigger on. Put a Tegra or whatever comes out next. We'll sell with a couple of versions. It'll have, by default, you know, all the software to do obstacle avoidance. And right now our SLAM is based on ceiling fiducials, the camera looking up at fiducials on the ceiling. So that's how we keep our price point low. So you can talk to me about it, and I can give you cards. I have cards now, so that's pretty cool. And also, we have a secondary project that Wayne's been working on. He'll talk about that
later.
Oh, later.
As president, I get to go last. Okay. Are you ready, Mark?
Yeah.
Okay.
Can I ask a question?
Yeah.
When you kickstart that, do you know what the price or the tier levels are going to be for the price points?
No. But right now, we're thinking the preliminary is we'll have 3 levels. So a low level will be around 600 to 800, and a high level will be 1,200. The higher level will have the nice designer shell on it and the complete sonar skirt, whereas the stripped down will just be the motor controller, maybe even without a computer, motor controller motors. You have to supply the batteries, that kind of stuff.
So basically, a turnkey system for like a little under $1,000.
Turnkey system for under $1,000.
Okay.
Uh-oh, it's not a clip-on. All right, well, got all my hands busy here. This is something that was here a few months ago, and it has grown. This is a FiddlerBot, and okay, there it is. And he's learned to recognize fiducial targets and go after them. If we get far enough, which if everything runs smoothly and I don't get kicked off the stage, we're gonna see him run a script that downloads a queue of commands to him. You can say, go and find an object, go and turn towards that object, approach the object, grab the object, lift it up, move it backwards, go and look for another target, which is going to be the one up on top. That'll say, I specify the numbers in the script. I'll say go to that target, and then when it gets there, it'll drop it down. All that is a just a little quick scripting language. You just put it in there. Basically, it's YAML files that are in a ROS topic format. Okay, so it's very straightforward from that standpoint. Now my trick is I'm going to have to put this down because I have to figure out how to plug in. I have a GUI here, and the GUI shows what he sees and also has JavaScript commands, so I can manually control it, or I can do this scripting thing that I mentioned that loads everything in. I think I have the right connector on there. So up here there is a. Oh, that's sweet. Oh, that's really important, actually. Yes, Mr. President. All right. What I need to do is plug this into the thing behind you because, like before, I'm going to show you what I'm doing on the screen with the JavaScript GUI. And as I recall, one of these is HDMI. So there it is right there. Okay. This one's HDMI. Let's see, it's going to there. So this is going to come out like this. And we need to select it. So there's actually a mild amount of setup, but I couldn't do this particular setup unless I stole the podium. So I'm going to plug it in here.
Whatever. It explodes. What's that?
Yeah. Google, they're nice people, aren't they?
This is a very nice.
Google's wonderful. Yeah. Yeah. It's a whole fleet of
It
them
showed
out
up.
there. You know, you don't get that around the country.
There we go. We have Connect. All right. Can you guys see that at all, or we have to do a little cable swing around or something?
Got blue screen over here, dude.
You've got a good monitor.
So we'd need somebody to run this thing here to switch in that HDMI port.
It says the HDMI is active, but maybe it doesn't like that resolution.
Actually, what was interesting is last time I used the same thing and it was really happy with it. So I'm not sure. We may have to just talk and I'll tell you what I'm seeing and I'll wave it in front of you or something like that.
Well, what we can do is he's got a camera. So what we'll do is we will.
Yeah, I'm going to turn this a little bit so the camera can sort of see what's going on actually a little bit better too. And the first thing I'm going to do is we can, yeah, so actually, that is too bad. Last time this worked pretty sweet. I need to actually run the GUI. So the GUI is showing a picture of where this fiducial is here. Down at the bottom I say it's number 4. So I'm going to say that I want to find that target. And this is all scriptable, so if we get, if I remember how to pipe something into a ROS topic using the publish command, and I think I remember it, we can run a little script later that'll be kind of cool. But the first thing we'll do is it moved around and found it with just the camera. So next thing we'll do is tell the bot to face the target. So he's going to face the target, adjust the cam to center again. That's what happened there. And now he's going to go to the target. This is all, his units are centimeters, and something's happened to one of the wheels. Oh good, nope, he can't see it. Oh my God, what happened? He's supposed to automatically pan down when he sees this thing. Now he's searching for it again. Unfortunately, he didn't pan down. When he gets close to something, he wants to like pan down. I may give him a little assist. Oh, I know why he's not panning down. It's because of my own stupidity. If I have him looking up too high, I told him I don't want you to pan down. So we're going to correct that here. And what I'm doing is I'm just saying tilt down commands. And on the GUI you can see up, no you can't, darn it. That's the sexiest part of this thing.
Yep,
Oh well.
on the other screen.
Yeah, I'm not sure if we can see it. But anyway, Okay, so now he'll be, oh, he did, he found it and approached it because I adjusted the cam downwards, and once it's below a certain level, he's allowed to look for it and so forth. So what I'm going to do is I have to back him up and all right, so what we see on the screen is him searching around for the fiducial, and he'll get to it in a second here, and then we'll have him approach it again. That was my fault for not having him set that first time. For some reason, it's way out the side of the screen, but it's in the center of his view at this point. He says on the GUI what he's doing, what goal he's on, and whether it's active. Now he's approaching the thing, and this time he's supposed to pan down. Hello.
Is that voice command?
Voice command. Voice command.
Oh, we're still at 148. It has to be.
Voice command.
Okay. Oh, did we get anything on the screen just now, or something happened?
It flickered.
Okay, what's happening now is he's actually rotating around because he didn't see it, because the cam is too high. I knew I shouldn't have dorked with this before I was leaving today. I can't get the tilt to drop low enough. So I'm going to do a stop on that, and now maybe it'll respond. There it goes. It's responding now. Okay. So it's dropping down with the camera again. We'll try that again, and we'll start him here. We're going to make it easier for him this time because we don't want to use up too much time. All right. All right. So now he's gonna find it and go towards it. We're definitely not going to have time for the scripts. I have one really cool script. It finds these 3 different objects, and as it finds them, it turns on the laser. And that's kind of neat. That's a quick one. The longer script, I'm going to forego the longer script. The longer script is doing everything I'm doing right now, just per a script. But it's going to take too long for us here. We're trying to keep the demos down. There, so now this time he did pan down. He got close enough to it. And he keeps it in view by moving down because he notices the object is up too high. So now he says he's done with that goal on the screen here, which sadly you can't see, but he says up there he's done. He also indicates which tags he sees at any given time. And so now he's going to move in for the kill, if you will. He's moving in and grabbing it. Now what I noticed is the string is loose. So yeah, see, so I saw the claw start to close. What happened here is the string got loose. So let's pretend he picked it up. But this part is really easy. It's a really cool little claw that off of one servo closes and then is able to raise up using just one servo, because once it grabs it, it bends the material and lifts it up. So let's just say that he's found it, and then we're going to say that he has. The script would have popped us up here to a higher altitude. And so I'm going to pan up higher. And this is kind of clumsy doing all this stuff without the script, but that's what we got. Okay, so now we're going to keep tilting up. And in the script, it just says go directly to a particular location for the tilt. What I'm having to do here is I'm having to manually tell it to go up each time, which is a little tedious. But anyway, we're almost there, and one more. Okay. Up 126. Well, maybe 126 will work. I don't know. Up 138. All right. Okay, actually it queues up things. So what it was doing is it was catching up to me. It was running kind of slow. But anyway, now we're set up to find this thing, which is now going to be target 7. So we're going to backspace and tell it to go to target 7. Okay. Now it's going to do a similar thing that it did before. I'm going to have it find that thing. So now it's panning back around to search for this object number 7, which is, I hope I put 7 on top. I don't know what I put there. By process of elimination, that's 5. I think that might be it. Oh yeah, it's finding tag 7, so it's got tag 7 in its view, and then I'm going to say go to it just like I did before. Now this time it's not really picking it, the claw's kind of busted, so it's going to just kind of scoot it, okay? It's just scooting it, but normally it's really cool. It grabs it and lifts it up, gives me the goosebumps. All right, now it's going to turn around. So the whole idea of this thing here, by the way, because it can keep searching, I could have set these anywhere on the table, but we'd be here for about an hour, all right? So it could have turned all the way around and found it and all that kind of stuff. All right, we're so close now. Just bear with me slightly longer. And there, oh, 7 is upside down, but I think the fiducials should work. No, it actually comes out in the AR pose thing. It comes out and finds it. So
right.
I think it's going to be okay. And even if it's not, we'll just fake it from this point, because basically it's got it in sight. It knows how far it is. It tells you the distance, and it tells you the angle off center it is. And now it says the goal. Okay, it still says the goal is active, but it should be really soon saying yes. There, done. Now he found it. And then I would tell it to drop the thing, which is a separate arm raise and arm lower thing. But since we're not going to do the whole show tonight, I'm going to turn on the laser, just for effect, because that's the coolest part. And I think we're going to forego the part where it just pans and finds the objects and just shoots the laser at them in the interest of time and all that sort of thing. But trust me, it does it. If you hang around afterwards, I'll run that part of the demo. And that's it.
Okay. Let's see, are you next, Ron? Bring it up and show us what you got.
Tough act to follow.
Hi, I'm Ralph. I'm the new guy. I have an embarrassingly simple robot here. It's a Ubiquity, uses an Arduino board. And initially I basically made this just a simple obstacle avoidance bot with the ultrasonic sensor. And if it gets a little too close, it backs up, turns, keeps going. And then I was on a hike with a buddy of mine who has a PhD in animal behaviors or something like that. He was telling me how rats are really, really good at learning mazes. And I thought maybe that would be the next step would be to build a bot that can do mazes, learn mazes, and try to be as smart as a rat. We'll see. But so I was trying to figure out how to do that, and I thought building a maze is kind of a pain in the butt. You know, you got to build walls and stuff, and then what if you want to change the maze? You got to move the walls, and it's just kind of a pain. So then I was watching some of the bot videos, and I saw line following robots, and I thought I could make a maze out of just lines and use the line follower type of approach and make a maze that way, and it's a lot easier to do. So basically I've started testing this bot with electrical tape on something like this, and the idea is you can make different turns and intersections in the maze with electrical tape and have this thing try to figure out where to find them or where they are and what kind of an intersection it is and how to get out of the maze. So That's basically what this is. I've got an array of infrared emitter detectors on the front of this thing to try to detect the patterns in the maze and go from there. I have a small power problem right now in terms of lighting up all these emitter detectors. It draws a lot more power than the Arduino Mega can source through its 5-volt regulator. So I had to come up with an interesting approach. I've got this proto board on top, and I snipped the V-in pin, sorry, the 5-volt pin going down onto the Mega board, and used the V-in and put a 5-volt regulator on top to source a couple more amps, so I can light up all these sensors. Now I just need a bigger battery, but at this point I just put the
bigger robot.
yeah, that's the next step too. Yeah. So anyway, it's something fun I've been working on, and I thought you know, this line maze thing might be some little competition I can organize if anybody's interested. It's kind of, you know, newbie stuff. It's nothing fancy like FiddlerBot, which is something I want to do at some point later on. But just a fun little project. That's pretty much it. Thanks.
Does it move?
Whatever happened to micro maze?
We talked about that the other night, and it's just, did Micro Maze even show up at Robo Games this time?
Not that I'm aware of.
Nobody entered.
Nobody entered, okay, so I believe Ted's the keeper of all the maze parts.
I am.
Yeah, but nobody did it. Very good. Moving robots are good.
Yeah. So
It's a stock and trade.
that's all he does is if he gets a little too close to something, he backs up and turns left. That's pretty much it.
Okay.
Yeah, yeah.
Very good. Okay, I have spaced out, who's next in the, or who has a robot?
Danny.
Is it Danny? Okay, Danny, you're on.
Test.
What's in the box, Danny?
So in the box is a challenge bot, which is based on the class that Wayne gave a while ago. It's a mess of wires and stuff. And after taking the class, I kind of ran with it and improved the kit and made a bunch of software updates and stuff. And so now I teach the class like Wayne used to. For anybody who is looking to build their first robot, it's basically a build your first robot kind of kit. And I too am gonna need another hand. Or, I don't know, I guess I could put the microphone down.
Talk loud.
Just talk loud. Hello, can you all hear me?
Yeah.
Okay. So there's two configurations that come default. So this is basically a class that you can take now. And I'll show you the two different things you can do once you're done with the class. Hopefully this works.
I'm excited.
Okay. Better not run off the table.
Need a leash on it.
Yes!
Yeah.
So it does that. That's one thing. Oh, hey. Hi. And then I just earlier tonight made a modification to it where I don't need to hook it up to the computer to switch what program, what behavior is running. So let's see if I can get that running. There's a button on here. Come on, button. Yes. Okay, so now if I put my hand over here, it does avoidance. Put my hand over there, and it does avoidance in the other direction. So these are the two behaviors that it does, and that's what I teach in the class. But the goal of the class is to get you from, like, maybe you've never built a shelf before to building one of these. And maybe you've never written Hello World, you don't even know what that means, to having a fairly decent understanding of what's going on in this robot. All the parts are sourceable from places like Home Depot or local stores. There's some people in the audience who've taken the class already.
How many people have taken the class?
I would highly recommend it.
Yeah.
It's a great class.
So right after Maker Faire, which I got into as a maker this year, so that's cool. Right after Maker Faire, there's going to be a session for Saturdays from 1 to 3, 2 hours starting at 1 p.m. at a hackerspace called Entropy. which is just north of 101 on Lawrence Expressway. And anybody who wants to take the class can email me at osloy@gmail.com. Or you could find the Entropy meetup. It's Entropy, ENTROPI, Entropy with an I at the end, on meetup.com, and you can look up the details there. So most of my students have been like 12-year-old or so, but I also have a fair number of people who were in my position where they're already like out in the real world doing software stuff, but they've never done anything hardware related. And yeah, that's the class. It's also, you can buy just this and not the rest of the class. This is $95 for the hardware, and then the class will hold your hand and make sure that you can get through all of the troubleshooting BS that happens, and it's 8 hours of class for $100. So the whole thing, you will go from 0 to this for $195, or you can buy just one part or the other. And oh yeah, all the source code is available online and all that jazz, and it uses all open source software for everything. So the wheel is 3D printed, and there's videos on YouTube about explaining the code and how to put it together and stuff. So if you wanted to, you could go find the list of parts and buy all the stuff and do it all at home. But I like it better if you pay me money.
Okay, very good. I should mention, I taught the class exactly once, and Danny just picked it up and ran with it. Okay, so.
It was a good class.
Yeah, thank you. Okay, any last robots for show and tell? Because I'm president, I always go last. Okay. I kind of work with the Ubiquity team here, and the question that came up with was, what are you gonna, if you're gonna do a Kickstarter, how do you give rewards for something as big as the Magni? And the answer is, well, you give a different robot. And this robot was designed to be the alternative Kickstarter reward. Okay, so it's going to be a less expensive robot that you can get as a Kickstarter reward. It will be software compatible with the Magni. Okay, it will run ROS, Robot Operating System, and we don't know what the exact price is yet because we haven't worked through our supply chain issues yet. But figure somewhere in the 100 to 250 range is kind of what I think is likely to happen. And the deluxe version will have the ARM, and the not so deluxe versions won't. And it's made out of a single printed circuit board. It looks to the rest of the world like an Arduino Mega. And then it runs off of the Raspberry Pi 2, which is the new quad-core ARM Raspberry Pi. And then I've been talking about ceiling fiducials forever, and one of these days we're actually going to show them off here, but we haven't done it yet. There is a upward pointing camera where we'll mount little things on the ceiling and auto map and localize using fiducials. So that is, it's called Loki, and we hope to be showing off Loki and Magni, oops, I'm sorry, Loki and Magni at Maker Faire. Okay. Thank you. So now what we're going to do is we're going to take a 5-minute break to allow our speaker to do their setup, and then we will start our talk. Thank you very much. 5 minutes.